the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Welcome to Further Mathematics lesson for senior secondary schools and colleges. Today we shall be looking at the topic matrices and determinants. What is a matrix? A matrix is a rectangular array of numbers that is subject to certain laws of combination. And by certain laws of combination, we mean addition, subtraction, and multiplication. So any rectangular array of real numbers arranged in rows and columns is called a matrix. If there are m rows and n columns, the matrix is called m by n matrix. In an m by n matrix, there are altogether mn entries. It is of order m by n, written m multiplied by n. Note, the number of rows is always listed first. 2. The number of rows is the same as the number of columns for a square matrix. 3. The diagonal matrix or the leading diagonal of a matrix is a diagonal containing the entries from the top left-hand corner of the matrix to the bottom right-hand corner of the matrix. This is an example. A11, A12, A13 up to A1n. A21, A22, A23 up to A2n. AN1 up to ANN. The matrix consists of those entries with the same rows and columns, subscript 1, 1, 2, 2, and n. 4. A matrix which has a single column is called a column vector. Example, matrix containing the entry 4, 1 is a 2 by 1 matrix. 2 by 1 matrix meaning it has 2 rows and 1 column. A matrix which has a single row is called a row vector, e.g. matrix containing the entries 9, 3. This is a 1 by 2 matrix. Why is it 1 by 2? Because it contains 1 row and 2 columns. What do we mean by column? A column is the vertical arrangement in a matrix, while a row is the horizontal arrangement of a matrix. Now let's look at definitions. 2 matrices are of the same order and they are equal if and only if all their corresponding entries are equal. Let's look at examples of matrix A and B. Matrix A contains the entries 2, 3, root of 4 and 0. Matrix B contains the entry 2, 3, 2 and 0. If you look at this example carefully, you know that the square root of 4 is 2. So the entries of the first matrix are identically the same as the entries of the second matrix. Whereas, if we have 2 matrices containing the entries 2, 3, 7, 1 and 2, 3, 7, 2, these matrices are not equal. That is why the 2 matrices there are not equal. When 2 matrices are of the same order, they are said to be conformable for addition. The sum of 2 m by n matrix, that is, considering matrix A with the element or the entry A1j and matrix B with the entry B1j, whereas A1j is the entry in the ith row and jth column of A, which are conformable for addition and is defined to be A plus B, which is A1j plus B1j with m by n columns. Example, matrix A contains the entry 1, 3, 2 over 3 and minus 4. And matrix B contains the entry 2, 0, 4 over 3 and 1. Now, if we want to add, remember the rule says two matrices are only addable when they are of the same order. You can only add 2 by 2 matrix or to 2 by 2 matrix, or 3 by 3 matrix to 3 by 3 matrix. If their order is different, it means you cannot add them. So let's look at the solution here. A plus B. The corresponding elements of those two matrices are to be added together, which means 1 will be added to 2, 3 will be added to 0, 2 over 3 will be added to 4 over 3, and minus 4 will be added to 1. If that is done, like in this case, you will find the sum of 3, 3, 2, and minus 3 at the end. Now, let's look at another definition. A matrix is Aij, is a matrix, and C is a real number. Then, CA containing the entry CAIJ having the rows m by n, and AC, which contains the entry AIJC containing the order m by n. Example, if you have half into matrix containing entries 2, 4, and 1, 6, it simply means that the half outside the bracket will multiply every element inside the bracket, which means every entry inside the bracket will be multiplied by the scalar outside it. That is half times 2, half times 4, half times 1, and half times 6. So that gives us 1, 2, half, and 3. Therefore, the sum matrix will be 1, 2, half, and 3. It's going to be a 2 by 2 matrix, because if you add a 1 by 1 matrix to a 1 by 1 matrix, the answer would also be a 1 by 1 matrix. And if you add a 2 by 2 square matrix to a 2 by 2 square matrix, the answer would also be a 2 by 2 matrix. Note the difference. A minus B of two matrices, Aij and Bij, is obtained by subtracting corresponding elements and writing the answers in corresponding position. Now let's look at the example. A matrix containing the entries 5, 4, 2, 3, and a matrix containing the entries 5, 4, 1, 9. So 5 will subtract 5, 4 will subtract 4, 2 will subtract 1, and 3 will subtract 9. At the end, you will get a difference of 0, 0, 1, and minus 6. Suppose A is a matrix which has m rows and p columns, and B is a matrix which has p rows and n columns. The product C is equal to AB, or A times B. It's defined as the order m by n matrix, each entry of which is determined by the following dot product. Cij, the ith row of A, jth column of B, that is, the number of columns in the first matrix must be equal to the number of rows in the second matrix. What this is saying is that if you want to multiply a matrix, there is a rule you must follow. And what is the rule? The rule says that if you want to multiply two matrices, the number of rows in the first matrix must be equal to the number of columns in the second matrix. If that is not conformable, then it means that your multiplication is not correct. Therefore, let us compute A matrix AB, which means matrix A times B. A is a 2 by 2 matrix and a B is a 2 by 2 matrix. How do we solve that? We have to take 4 different multiplications. C11 is a product of the first row and the first column in the second matrix. So which is 6 times 3 to give you 18 plus 8 times 4 to give you 32. That gives us C11. C12 is a product of the first row and the second column in the second matrix. which is 6 times 5, which is 30, plus 8 times 0, which is 0. C21 is a product of the second row and the first column in the second matrix, which is 1 times 3 and 4 times 4, which gives you 3 plus 16. And C22 is a product of the second row in the first matrix and the second column in the second matrix, which is 1 times 5, which is 5, plus 4 times 0, which is 0. At the end of it, C11 is going to be 18 plus 32, which is 50. C12 will be equal to 30 plus 0, which is 30. C21 is 3 plus 16, which is 19. C22 is 5 plus 0, which is 5. So the product matrix AB will be equal to 50, 30, 19, and 5. It contains those entries. Example 5. If A is 2, 1, 3, 4, and B contains the entries 0, 1, 5, 7. Let's check if C is equal to AB. So let us look at the important properties of matrices. Using definitions 1 to 5, we can deduce some properties of matrices which are important and in some cases unusual. Given the matrix theta is equal to 0, 0, 0, show that A plus theta is equal to theta plus A. We want to show if addition of matrix is commutative. So for any 2 by 2 matrix. So you now have A11 matrix A containing the entries A11, A12, A21, A22. Property number 2. Show that A multiplied by theta is equal to theta multiplied by A, and is equal to theta for a defined matrix in 1 above and for any 2 by 2 matrix in A. Conclusion that we can derive from 1 and 2 is that the matrix theta performs multiplication for the row which is 0, and it performs the same row as a 0 matrix, and addition and multiplication have the same commutativity. Therefore, theta is known as a 0 matrix. Let A be 0, 0, 1, 0, 1 and B be equal to 1, 0, 0, 0. Find AB. It means we multiply AB. When we multiply AB, the conclusion we can draw from it is that the product of 2 matrices can be the 0 matrix, even though neither of the matrices itself is a 0 matrix. This is an unusual property because real numbers AB, if the product of AB is equal to 0, either A is equal to B or B is equal to 0. Or both A and B will be equal to 0. Let I be equal to 1, 0, 0, 1. Show that AI is equal to IA and is equal to A. This I is known as identity matrix because in the leading diagonal we have the entries 1, 1 from the top left hand corner to the bottom right hand corner. For any 2 by 2 matrix, A is equal to A11, A12, A21, A22. Now, the conclusion we can derive from it is that the matrix identity for matrix 1 plays vital role in the product of numbers. I is called the identity matrix. Let A be equal to 1, 2, minus 1 and 1. B be equal to 2, 3, 4 and half. Calculate AB. B, calculate BA. C, calculate what you notice. Conclusion. Matrix multiplication in general is not commutative, whereas matrix addition is commutative. Thank you, and I hope to see you next